Right, so in this same episode, we now wish to do what? To solve some problems that considers the possibility of inserting more than one arithmetic mean in between two numbers. Now, this question here is demanding for us to insert four arithmetic means between the number 17 and the number 29. We want to insert four arithmetic means in between the number 17 and the number what? 29. Remember I said that if you are given two numbers, that it is possible for us to insert more than one arithmetic mean in between the two numbers so that we can now form a sequence that is in arithmetic progression. Or in the other way around, whenever you insert as many arithmetic means as possible in between two numbers, you are expected to form a sequence of numbers in arithmetic progression. But the issue now is that the four arithmetic means we are looking for that should be inserted in between 17 and 29, we don't yet know it. And remember, in mathematics, whatever thing you don't know, you can use symbols or letters to represent the unknowns. So here, we are going to use some symbols to represent the unknown arithmetic means, which we intend to insert in between 17 and 29 to form a sequence in arithmetic progression. Now, solution. We now start. So I can just say, let the arithmetic means be, let it be MO1, MO2, MO3, and MO4. Such that the sequence, when you insert these four arithmetic means in between 17 and 29, that is 17, MO1, MO2, MO3, MO4, 29, you are meant to form a sequence in what? Arithmetic progression. So we have simply formed a sequence in arithmetic progression by doing what? By inserting four arithmetic means in between 17 and 29. So this example also tells us that it is possible to form linear sequences, or it is possible to form arithmetic progressions when you are given two numbers. When you are given two numbers, let's say I have a number like 2 and 6 or 2 and 4. How can I form a sequence in arithmetic progression using 2 and 4? Very simple. To form a sequence, an arithmetic sequence with 2 and 4, what do? You simply do what? Insert the mean of 2 and 4 in between 2 and 4. When you do that now, the sequence you have formed is what? Is an arithmetic progression. That was what we looked at in the previous exercise or the previous video we had. But here, we have a different something altogether. So here we are given two numbers as 17 and 29. Okay? I want to find the arithmetic means in between. I want to insert four arithmetic means in between 17 and 29. But those means we want to insert, we don't yet know them. So we can just say let the means be M1, M2, M3, and M4. But we know that when these arithmetic means are inserted in between 17 and 29, we are going to form a sequence of numbers in arithmetic progression. And that is the definition of arithmetic progression. So now, this sequence of numbers is in arithmetic progression. For this sequence to be in arithmetic progression simply means that we are claiming that what? That there exists a common difference between any two consecutive terms of this sequence. But that common difference, I repeat, for this sequence to be in AP means that we are claiming that what? That there exists a common difference between any two consecutive terms of this sequence. But this common difference of this AP is unknown to us. So we have to find a common difference. But if you look at this sequence in AP, the sequence in AP we have formed, how many terms do we have here? Let's say this is the first term, second term, third term, fourth term, fifth term, and the what? And the sixth term. So this AP contains 6 terms. Among these 6 terms, only 2 are known. The first term is known, and the what? And the last term, which is the sixth term, is known. So in mathematics, we always work from the known to the what? To the unknown. We use what is given to get what is not what? Given. So here, I will use these 2 things given to me, be it being the first term and the what? And the sixth term, to get the common difference, and also get what? And also get the arithmetic means. M1, M2, M3, and what? And M4. So now, how do we go? From this sequence, we have seen that what? We have seen that the first term A is equals to 17. And the second term, which we normally give as T sub 2, is equals to M1. The third term, T sub what? 3 is equals to what? M2. The fourth term, T sub 4 is equals to what? M3. The fifth term, T sub 5 is equals to M4. And finally, the sixth term, T sub 6 is equals to what? 26. Now, taking note that the sixth term, T sub 6, we are given that our T sub 6 is equals to what? 26. But in this case, this our sequence is in arithmetic progression. For a sequence in arithmetic progression, the sixth term has a representation. The sixth term of a sequence in arithmetic progression is normally represented as what? As A plus 5D. So it means our A plus 5D. And what is the value given? The value is 26. Now this now means, but remember here that the first term is given to us from the question. The first term is what? 17. So we can insert the value of the first term into this expression or into this relation. It now means that 17 plus 5D is equals to 26. Which now means that we now make our D, so this is 5D is now equals, when 17 is now crossover, it becomes minus. Becomes 26 minus 17. So this simply means that the value of 5D is equals to what? When we calculate, let me verify this. 26 minus 17 gives us 9. So it gives us 9. So if I now write over here, what it simply means is that we have that 5D is equals to 9. Is that 9? 17. Okay. That is it. Okay, 9. So 26 minus 17 gives us 9. Okay, so that this now means that what? This means that the value of D will now be equals to 9 over what? Over 5. The value of D will now be equals to 9 over, is this 26 or 29? This is 29. Okay, oh my God. This is 29, sorry. Let's change that, this is 29. The sixth term, 29. All right, no wonder. Okay, this is 29. So that 29 minus 17 will give us 12. Okay? How about 12? So this is 12. And this is 12. Okay. So having gotten that, so having the value of D, remember we have the common difference now as 12 over 5. And we have the first term as what? 17. And we are looking for this MO1, MO2, MO3, and MO4, which are the terms of this sequence. But remember that whenever the terms of a sequence in AP is missing, the terms can be found when the first term and the common difference is what? Given. So once you know the first term and you know the common difference for a sequence in arithmetic progression, you can find any of the terms of the sequence. So now we intend to find the second term, which is the arithmetic mean M1, the third term, which is the arithmetic mean M2, the fourth term, which is the arithmetic mean M3, and the fifth term, which is the arithmetic mean M4. So we now proceed to calculate all these things. All right. Now, okay, so now the arithmetic mean M1 is actually equals to the second term of this sequence we have formed in AP. This now means that the arithmetic mean M1 will be equals to the second term, given that this sequence, the sequence we formed is in arithmetic progression. the second term of any sequence in arithmetic progression is normally given by the expression a plus d. I believe you will never forget this. So this now means that our MO1 will be equals to, remember, the value of a is given as 17, plus the value of d is given as what? As 12 over what? Over 5. This now means that our mean MO1 will be equals to, I believe by the time you resolve this, you have 17 plus what? 12 over 9. This gives us 55 over what? Over 5. Okay, over 3, please. Okay, 55 over 3. Let me recheck that. Please help me out. This is, what do we have? This is second term is MO1. So this is, second term is A plus D. Okay, that's correct. A is 17 plus our D is 12 over what? 12 over 5. 12 over 5. Okay, that's okay. That's correct. So we'll have it as what? 17 plus what? Plus 12 over 5. And that results to, see, this is 97 over 5. That's the correct thing there. Okay, so we now move again. Next, we can equally find the what? The third term, which is MO2. So now, the next, our MO2 is equals to the third term, which means that our MO2 will be equals to, for a sequence in AP, the third term is given as A plus what? 2D. And that simply means our MO2 is equals to, what is the value of A? The value of A is 17. So this means 17 plus 2 into bracket. What is the value of D? The value of D is what? 12 over 5. So that this now means our MO2 will be equals to 17 plus 12. 2 by 12 gives us what? 24 over 5. And this now means our MO2 is equals to 17 plus, we resolve 17 plus 24 over what? Over 5 gives us, this is equals to 109 over 5. Then again, we can equally find what? We can equally find the MO3, the third arithmetic mean. Now, next, the third arithmetic mean, MO3, will be equals to the fourth term of this sequence in AP. Will be equals to what? The fourth term of this sequence in AP. This now means that the third arithmetic mean will be equals to, remember, for a sequence in arithmetic progression, the fourth term is given as A plus what? 3D. So this simply means that our third arithmetic mean will be equals to, what is the value of the first term? 17 plus 3 into bracket. What is the value of the common difference? 12 over 5. And this now means that our MO3 will be equals to 17 plus 3 by 12 gives us what? 36 over what? Over 5. So when we now resolve this, the third arithmetic mean will be equals to, if you add that up, you have 17 plus what? 36 over what? Over 5. And I think that gives us 121 over what? Over 5. Then we can equally finish up the work. So we can equally find the what? The fourth arithmetic mean. The fourth arithmetic what? Mean. The fourth arithmetic mean. Then finally, the fourth arithmetic mean, MO4, will be equals to the fifth term of this sequence in arithmetic progression. This now means that the fourth arithmetic mean will be equals to, remember, the fifth term of any sequence in arithmetic progression is normally given by the expression A plus 4D. And that simply implies that the fourth arithmetic mean will be equals to, the value of A is given as what? As 17 plus 4 into the value of the common difference, D, is given as 12 over 5. And that now means that the fourth arithmetic mean will be equals to 17 plus 4 times 12 gives us 48 over what? Over 5. So when we resolve this with our calculator, we can have this as 17 plus 48 over what? Over 5. That gives us 133 over 5. So this means that the fourth arithmetic mean will be equals to 133 over 5. So, ladies and gentlemen, we have come to the concluding part of this problem. We have been able to find the arithmetic means, MO1, MO2, MO3, and MO4. And we have equally seen that if we insert these arithmetic means in between 17 and what? And 29. We are going to form a sequence in arithmetic what? Progression. You don't just stop at finding these arithmetic means. You have to insert them in between 17 and what? And 29. So you now say, therefore, the sequence we now want is what? 17, comma, our MO1, which is 97 over 5. MO2 is what? 109 over 5. MO3 is what? 121 over 5. And, okay, let me do this one by one. Now, remember, we are forming a sequence in AP as what? 17, comma, MO1, comma, MO2, comma, MO3, comma, MO4, comma, MO1. Okay, that's all then, comma what? Comma 29. And this sequence was actually in arithmetic progression. So have M1, M2, M3, M4, and the rest of them. So, but we have found the value of M1, M2, M3, and M4 as all this. So that we can now become, this now becomes 17, comma. M1 is what? 97 over what? Over 5. And MO2 is what? 109 over 5. And MO3 is what? 121 over 5. And MO4 is what? 133 over 5. And then this is now what? 29. So we have been able to insert the means in between the number 17 and what? And the 29. That we form a sequence in what? In AP. So this is what this episode tries to focus on. So we have more questions in this aspect or in this particular area. But in the next question we are going to solve, the value of the first term is not given, and the value of the last term is not given. But we are expected to insert some arithmetic means in between the unknown numbers. So why that exercise comes to play is that they want to let you know that irrespective of what the numbers is, be it a whole number, be it a decimal number, be it a fraction, be it whatever type of number, be it a natural number, you can easily insert as many arithmetic means as you wish in between the given numbers. Thank you very much for being part of this video lecture. I wish you can join us more in the subsequent classes we're going to be having. Keep on subscribing, keep on watching more videos to equip yourself at home mathematically. Thank you, and God bless you.